Greetings everyone, you're welcome to this video tutorial. In this tutorial, we will talk about flow of control. In a program, the execution of statements can be sequential, selection, and iteration. But before understanding them deeply, let us talk about flowcharts. What is a flowchart? A flowchart is a step-by-step pictorial representation of solution to a problem. It shows the logic of a program and it emphasizes individual steps and their interconnections. Flowcharts helps to understand the flow of the program and easily debug the program and act as an analytical tool. So it becomes important to draw flowcharts before writing a program because it is important to understand the flow of the program before actually writing the program. And flowchart helps us to understand the flow of the program and they show the logic of the program. So let us learn about how to make flowcharts, and for this let us see what all symbols are there which represent different things in a flowchart. The very first symbol is an oval. This is called a terminal box and it is used to represent the start and end of a flowchart. So you can see here it is written, it defines the starting and ending point of a flowchart. The next symbol is a parallelogram. It is an input or output box and it is used to input data and output data. So whenever we have input or output in a program, we use this symbol, parallelogram. Then we have rectangle. This is a process or instruction box and it is used for performing calculations. Then the next symbol is a rhombus. This is a decision box and it is used for condition-based processing. So whenever we have some condition based on which we have to perform some action, we use this symbol. Now these are the four different flow lines in four different directions and they show the direction of flow of the program logic. And the last symbol is a connector and it connects to a flowchart. So sometimes we have a very big flowchart and it does not fit on a single sheet of paper. So we can break the flowchart into two or more flowcharts and then we can connect them using a connector. Sequential construct. It is the default flow of statements and causes execution of statements in a sequential or linear order. So you can see the default flow of statements in any program is always sequential. That is, the statements are executed in a sequential manner, one after the other. So if we have statement 1 as the very first statement, so this will be executed and the execution of statement 1 is followed by execution of statement 2, which is followed by execution of statement 3 and so on. This is called a linear order or sequential order. So let us see few examples of sequential construct. The very first question which we are considering is input two integers, calculate and display their sum. Now let us make a flowchart for this. So we will begin with a start symbol. So this indicates the start of the flowchart. Now as we have to input two numbers, the next statement will be input a comma b, where a and b are variables to input the values. Now to calculate the sum of a and b, we will write down the statement c is equal to a plus b. Now we have got the sum. To display it, we use a parallelogram and write down the statement output c. This will display my sum. And this is the end of my program. So end of my flowchart. So I will put the end symbol to indicate the end of the flowchart. Now let us consider one more example. Input side of a square, calculate and display its area. So again, to indicate the beginning of a flowchart, I will use the symbol start. Now in this, I have to input side of a square. So I will write down the statement input side. To calculate the area, I will use this formula, area equal to side into side. And after calculating the area, I have to display it. So I will use the output statement, output area. Now this is the end of my flowchart, and so that I will put this end symbol which indicates the end of the flowchart. So in all both the flowcharts, you can see the arrows, they are moving in one direction only, from top to bottom. You can see all the arrows are moving from top to bottom. Similarly, in this flowchart also, all the arrows are moving from top to bottom. Thus, the flow of program is sequential or linear. So this type of flowcharts, in this type of flowchart, the flow of the program is always sequential or linear. There is no branching anywhere. This type of flow is called sequential. Let us talk about now selection or conditional constructs. It means execution of statements on the basis of a condition. So we are giving some condition. You can see in this diagram, a condition is given, and on the basis of the condition, if it is true, a set of statements executed. In this case, statement 1 is executed, and if the condition is false, statement 2 is executed. So you can see here there is a branching, and there are two different paths, one for the truth value of the condition and one for the false value of the condition. Again, we can see if the condition is true, one group of statements is executed, and if the condition is false, another group of statements is executed. So this is called conditional or sequential or selection construct. So let us see a few examples of selection construct. Now the question is input a number and display whether it is even or odd. So in this case, again I will start with the start symbol, and then as I have to input a number, so I'll give the statement input A. Now I have to check whether this number is even or odd. For this, I will use a rhombus as a decision box. I will write down the statement if A modulus 2 equal to 0, as modulus gives the result of division of A by it gives the remainder of the division of A by 2. And if the remainder is 0, if after dividing by 2, the remainder is 0, if it is truth, then I will display even, and if it is false, I will display odd. So you can see there are two paths. If the value is true, I will display even, and my flow will come like this, and here my program will end. And if it is false, it will display odd, and the program flow will be like this, and it will end here. So you can see there are two different paths. One path is this, and the second path is this. So out of these two paths, only one path will be executed depending upon the outcome of this conditional expression. Now let us talk about one more question. Input a number and display whether it is positive or negative. So again, the program will start, or flowchart will start with a start symbol. I will input a number, and now I have to check whether it is positive or negative. So my conditional statement will be if A greater than equal to 0. If this condition is true, it will display positive and the flow of control will move like this. And if the result of this condition is false, it will display negative and flow of the program will be like this, and ultimately my program will end here. So in both the cases, you can see that the direction of arrows in the above flowcharts is not always linear, and the direction of flow takes turns at the junction of a rhombus. So you can see if this is the rhombus, at the junction of the rhombus, it is taking a turn. At the rhombus junction, the flow decides which way to proceed after checking a logical statement. So after checking this logical statement, it will be decided where the program flow will go, either this way or this way, and thus creating two different paths following which the program logic flows. So at the junction of the rhombus, there are two different paths, and according to the conditional value of this conditional expression, either this path will be taken or this path will be taken. Now the next thing is selection construct types. Now conditional statements, they are used in situations having multiple paths of execution. Whenever we have multiple path of execution, conditional statements are used, and each path leads to different types of completion states. So there are two types of selection statements, if else and switch case. The selection statements are also called conditional statements or decision statements. Now let us talk about iteration or looping constructs. It means repetition of a set of statements depending upon a condition. So you can see in the diagram, a condition is given to you, and if the condition is true, a set of statements is executed, and then again the condition is checked, and if it is true, again the set of statements is executed. And this will happen unless or until the condition becomes false, and when the condition becomes false, the flow of the program will be like this. It will take this path. So the set of instructions are executed repeatedly till a certain condition is true, and it stops when the condition becomes false. You can see here, this set of statements is executed repeatedly again and again till the condition, this specific condition becomes false, and when it becomes false, it follows this path. So let us take few examples. Now the first question is display hello 5 times on the screen. So we'll start with the start symbol, and then I will declare one variable k, and I will initialize it to value 1. Now I will check whether k is less than equal to 5 or not, because I have to keep count till 5, as I have to display hello 5 times on the screen. If it is true, then I will output hello on the screen, and then my flow of program, you can see flow of control is like this. It will go up, and then this statement is executed, which is k is equal to k plus 1. And again it goes like this, and after this it will again check this condition. So earlier my k was 1. So after this statement, k will become 2, and it will again check. As 2 is less than equal to 5, the condition is true. It will output hello. After that, it will move up. Again, k is equal to k plus 1. As k was 2 earlier, it will become 3. And my program control will flow like this, and it will come down, and it will again check, is 3 less than equal to 5? Yes, it is true. So it will again display hello, and it will again move up and increment k by 1. So k will now become 4, and it will move like this again. You can see here, and it will again check whether 4 is less than equal to 5 or not. Yes, it is true. So it will display hello, and then again it will move up. As k was 4 earlier, it will become 5, and it will again move like this, and again check 5 is equal to 5. If it is not less, but it is equal to 5, so again the condition is true. It will display hello, and then it will move up. K is again incremented by 1, and now k will become 6. So my control will move like this, and again it will check. As 6 is neither less nor equal to 5, the condition will become false, and so it will follow this path, and my program will end. And the output of my program will be that it will display hello 5 times on the screen. Now let us take one more example. Display numbers from 1 to 10. So again, I will start with the start symbol. Now again, k will be initialized by 1, as I have to go from 1 till 10. So my condition will be that k should be less than equal to 10. Now if the condition is true, it will display the value of k, which is 1, and then the flow will go like this, and k will again be incremented by 1, and k will become 2. The program flow will flow like this, and again it will check is 2 less than equal to 10. Yes, so it will again display 2, and again k will be incremented by 1. So you can see here again the program flow will flow like this, and it will again check 2 less than equal to 10, and for the true value it will output k, increment k by 1, and again condition check is there. So this action will be repeated 10 times, and when the value of k will become 11, this condition will become false, and my program will follow this path and it will end. So you can see the steps after the rhombus are repeated if logic in the rhombus produces a true value. So these are the steps which are being repeated repeatedly, and a cycle is formed between the rhombus and the steps after it. You can see the cycle, this step of these steps, they form a cycle, and this cycle is repeated till the condition becomes for the truth value of this condition. So these steps are kept on performing for the truth value of this condition, and when this value becomes false, the cycle breaks. This cyclic path of execution is referred to as an iteration in C++ programming jargon. So this is called iteration. Every cycle is called one iteration. Now iteration or looping constructs types. There are 3 types of iterative or looping statements, and these are for loop, while loop, and do while loop. So let's revise. Here are few programming situations which are categorized according to the type of flow of control they require, that is sequential, conditional, or iterative. So let us study the situation and identify the flow of control. The first situation is Dinesh wants to find simple interest on a given amount at a particular rate of interest for fixed number of years. So you can see here in this situation, Dinesh just have to input the required things, and he has to put the formula of simple interest to calculate simple interest. So there is no branching, nothing. So this is an example of sequential flow of control. Let us take the second situation. Rajat wants to check whether his weight is an odd number or even. So in this case, you can see you have to input weight and you have to check whether it is odd or even. So in this case, branching is there. So this is an example of conditional flow of control. Now consider the next situation. Sarla wants to calculate area of a triangle using Heron's formula. So in this situation, you can see Sarla needs to calculate the area of triangle. This is a simple calculation. So this is a sequential flow of control. You consider the next situation. Teacher wants to calculate total and percentage for 40 students of a class. So you can see here the formula for total and percentage will be repeated 40 times for all the 40 students. So we are repeating the same step 40 times. So this is an example of iterative flow of control. Let us take another example. ABC company wants to calculate salary of all 100 employees working in it. So again, in this case, the formula for calculating salary has to be repeated 100 times for all the 100 employees of the company. So this is again an example of iterative flow of control. Let us see the last example. Mera Bank wants that its customer will be able to draw money from their account only when there is a minimum balance of rupees 100 left in their account after the withdrawal. So there is a condition that withdrawal can be done when a minimum balance of 1000 rupees is there in the account. So again, this is a case of branching in which on the basis of a condition, a withdrawal can be done. So this is an example of conditional flow of control. So this is all for this video. I hope you like this video, and if you really like this video, kindly give thumbs up, and you can also subscribe to my YouTube channel. Thank you.